Okay, hi everyone, and welcome back to the first session of day 2, week 2, the first session. Today we're gonna take a look at sentiment analysis on an advanced view plus keyword extraction, and we're gonna take a look at some demo that's related to this session as well. So if you have any questions, as always, please just raise your hands or just you can stop me and open your mic and speak or write in the comment. Okay. Let me share my screen. Yeah. Okay. Can you guys see my screen, guys? Can I get some confirmation? Okay. Good. I think it's going to remove someone, but they can join right back. Okay, so Zamzam, so you're gonna be removed. I don't know why, but please make sure to just join right back. Okay. Okay. So let's take a look at today's session. So we're going to talk about, as I mentioned, sentiment analysis. Since we have seen it earlier on the past week, we're going to have more of an advanced and a deeper level understanding about sentiment analysis and, of course, keyword extraction. So let's get started. So since we already know or have seen these things in the previous week, the slides might maybe just a bit shorter. So we're gonna focus more on the demo. Okay, so let's start with the segment analysis. Yes, is that a question? Can you share the of course we always share the slides and like the notebooks always.
It's
Is that a question?
possible. Can you hear me?
Yes, we can.
It's possible. Can you share us a quick collab file for this demo?
Yes, I was just saying that we always share at the end of the session. So I will share at the end of the session. So I think you already have the link to the drive, right?
So there.
I think you're breaking up a bit.
ለማለት የፈለኩት ምን ነበር መሰለህ? አሁን ሼር ብታደርገን አንተ ከፍተህ ስታሳየን እኛም ጎን ለጎን እዚሁ ከፍተህ እንድናየው ፈልጌ ነበር። ለዛ ነው።
Yeah, sure. Why not? If you can, then I think it's better for you guys to follow up. But if you want, I think we can do that as well. Let me just share the slide, the collab here. Okay, here you go. Okay, so yeah, so let's get started. So what is sentiment analysis? So like we have seen it earlier on the past week. So sentiment analysis uses like natural language processing and the toolkits to determine the emotional tones of the text and classify it as positive, negative, and neural network. And you can also like measure it or analyze it on the scale of the negative one, which is the most negative, and to positive one, which is the most positive, plus the neutral, which is on the 0 mark. So how is it important, or how is it useful for this week's problem or for this week's project? So it gauges the customer satisfaction in their experience, which is what you're going to be doing or what you are doing right now. Plus, it identifies areas of improvement for the app. So you cannot, like, I think we have also talked about this earlier, but you cannot go through every comment or every review manually, because it's really time consuming and it needs a lot of labor. So by using this sentiment analysis, you can see how satisfied they are, plus what their experience is like. Plus, you can identify areas of improvement. Which part do you have to improve for the bank? Is it for the UI, or is it hard to understand, or is it for latency, or is it like data privacy, or so on and so on? So which part do you need to improve? You need to get that from the customer. Plus, supports the competitive analysis by comparing users' sentiment. So it's a lot, like it's really, really good, and it's really, really important to take a look at or to know how to do this sentiment analysis. So some of the applications, of course, include prioritizing feature updates based on the user feedback. So like with limited number of labor or workers, you might not be able to like answer or like include all the features that the user wants, but you can prioritize based on this feedback and do on the highest priority features first. And of course, you can also measure brand perception, how people see your brand. You can also see that. Enhance the user customers, enhance the customer support strategy. So how you can support the user more, you can also enhance these strategies just based on the reviews. So it's really important, and we need to know how to do it. And of course, with the keyword extraction, we also have keyword extraction identifies significant words or phrases that are presented the key terms in the topic of the text. So under the review, which words or which phrases are more important, I would say, or more significant than the others. So that's what basically keyword extraction means. So it's really important to also know this, because it guides the development of the app by focusing on the features that the user mentioned, because some words or most of the words may be related to the features that the user wants to see, or what the user is most happy about or most disappointed about. So based on these keywords, you can gauge your app development to just better develop those features. Plus, it informs the marketing strategy with user preferred terms. So the terms that the youth companies use in their marketing campaigns, and in others, just to get the users, could be also extracted from these keywords. And of course, identify trends for product improvement. How do you want to improve? Where, like, what's the brand perception from the people, and which phrases are being used the highest could also help you in this area. Highlight common phrases like user friendly, and complaints like bugs and so on. So if a lot of people are talking about bugs, and your keyword extractor extracts the word bug by we will see the methods also as well. So it means that it could be a complaint and there's a bug, so you need to fix it. And if the keyword is user friendly, it means that your app is doing good in the user friendly or on the UX part. Plus, it reviews frequently mentioned features or issues. So I don't know if it has been used in our country yet, but a lot of companies, like when people find bugs, they post about it online, like on platforms such as X, especially, and people would like pick it up, and when it grows, the company will know what this issue or what this feature is, and so on. So yeah, that's one or some of the applications and importance of keyword extraction in or for application reviews, which you are doing right now. I'm sorry. Yeah. Okay. So let's take a look at some of the sentiment analysis methods, and then we will see some sentiment analysis techniques. Okay. So the first one actually the first one and the fourth one are pretty much similar with each other, but the fourth one is just some additional rules on top of the lexicon dictionary based sentiment analysis. So what is the lexicon based method? So there is something called, let me just dictionary. So here we have the lexicon dictionary that you can see. So you can also download it and take a look at it, and so on and so on. But what the lexicon dictionary really is just what the like what sorry, I think we are here. So the lexicon based method of sentiment analysis uses these predefined words, the list of words and their sentiment score from the dictionary in order to identify if the word or the phrase is positive, or if the phrase is negative or just neutral. So it's just uses predefined list of words that are already defined or written, or which you can find in the lexicon dictionary. It's a dictionary with along with their sentiment score. So this has some good part and some bad part. So it's already trained on the data on the dictionary, so it's really fast and it's really simple to use, but it misses a lot of context because for example, if we say, oh, that's sick, right? Like the word sick could have a lot of different meaning based on the context, right? So if I say, if someone does like a really good backflip, and I say, oh, that's crazy, like I seen like admiring their work or their athletics, uh, it's positive, right? If you take a look at the whole context, but for this type of methods, it kind of misses this. Misses this point, this whole point, and just goes ahead and sees the word sick, and okay, so sick is negative, so the whole thing should be negative, and it misses the context. And of course, it has a poor handling of negation and sarcasm. So it doesn't understand sarcasm. So if you are being sarcastic and use a negative word to just motivate people or do something positive, it will, of course, take it as a negative thing. So that's one of the most or the biggest fallbacks or limitation of the using the lexicon, and of course the rule-based method. So text blob, which we used last time, plus Vader are also examples of the lexicon. Of course, Vader could be, so primarily they are lexicon, but they are also rule-based methods, but we will also see them, okay? So some of the applications of this lexicon-based method could be quick sentiment analysis, or gauging, social media monitoring, and so on and so on. So just for a quick lookup, okay? For the machine learning based method, so you train a model like Naive Bayes SVM on a labeled data, and then train your model, and then use that model in order to determine if a word or a phrase or a sentence is positive, negative, or neutral based on the pre-labeled data, or based on this trained model, okay? So these features are it learns from context, because when you label the data, so it requires manual labeling, of course. So when you label the data, you know the whole context. So the model kind of knows how to learn from context. It adapts for different domains. So based on the trained context, it can adapt to different domains. So phrases used in, let's say, or for Amazon, and the model used for, let's say, for the app review could be very different, because the wordings or the data that it's trained on are different. So that's a good thing that you can it can adapt for different domains. And limitations are it requires labeled data, which is a lot of work, could be a lot of work in order, actually, that's based on your expectation of how good you want the model to be, of course, and risk of overfitting is another issue as well. So some of the applications, of course, include customer feedback analysis, which you're going to be doing, I believe, and detailed sentiment classification. So this is better than the Lexicon. And what's better than the machine learning are the deep learning based models, which is just utilizes neural networks such as BERT and LSTM for advanced context understanding. It has a higher accuracy than the previous one and captures more complex linguistic nuances. And but of course the limitation are it requires a larger dataset and it's pretty much computational intensive than the previous ones. Okay. So the of course applications include aspect-based sentiment analysis and complex text analysis as well. So the rule-based, as I have said, it's pretty much similar with the first one, but it applies manually defined rules for sentiment classifications. So it's transparent, it doesn't train on any data. So some examples could be the weather. It's primarily the Lexicon method, but also it can be classified under the rule-based one. Plus, it's difficult to scale. That's the limitation and might not cover all cases because of the limitation of the manually defined rules. And applications, of course, include specific use cases and initial prototyping if you want to see, if you want to see what's going to happen or how good your model is or your pipeline is. So some of the pros and cons of using each method could be, so for the Lexicon and the rule-based, they're really fast. They are really like it doesn't require any trained data. The Lexicon is very fast and easy to do, but the rule-based is very transparent, but it misses context both, and it's poor in negation handling, but and of course it's hard to scale and may miss some cases for the rule-based. For the machine learning and deep learning, their highest drawback or con is the need for data, external or extra data. For the machine learning, you need labeled data, and for deep learning, you need a higher or a much larger data. Sorry, yeah. Plus, but the good side of it is it handles context more, or better, and it's more accurate than the Lexicon and the rule-based methods. And for the deep learning, it's the best so far. Plus, it captures nuanced cases. So that's the different types of methods, the four methods of performing analysis of sentiment. When we see some examples of these methods, so for the Lexicon-based, and of course, you can also label this as rule-based because they are also rule-based methods. We have the text blob, which we have used on the past week. We will also see it for this week, plus the weather. So these are simple libraries for quick sentiment classification, and the weather is optimized for social media and reviews and handling. It also handles emojis and slangs, which is just a layer done by the rule-based method. So you can see that text blob as just a Lexicon-based method, and the weather as rule-based, which is just an addition on the data. Okay, so they are both first weather. Sorry, I said weather, but I meant Lexicon. Okay, so and for the machine learning methods, we have the Navy base, which is just probabilistic classification of text data, and SVM, which is effective for high dimensional text features. And for the deep learning method, We have the LSTM and the BERT, which is just a transformer, like which it captures sequential context in reviews, and for the BERT is advanced model for nuanced sentiment understanding. So we don't have, I don't think that we have the data and the labeled data for this one, but we will try to see with what we have. Okay, so the next one is the text, the keyword extraction methods. So as we did earlier, we will just see the different methods of keyword extraction, and then we will see some techniques of how we can do this. And then I think we will see some pros and cons, and we will move to the example, okay? Okay, so let's say, so we have the frequency based, which is the most easiest thing to do, or the easiest method, I would say. So it identifies most frequent words after removing stop words. So if you don't remove stop words, I would definitely tell you that the highest or the keywords that are going to be extracted are going to be the stop words. So stop words means for example, you can see the, are, she, he, like this kind of things that are called stop words. You need to remove them first, and of course clean them. We will see how we can do that as well, and then do the key extractions. Okay, so after removing them, counting the frequency of the words is going to be classified under the frequency based method. So it's very simple. It's really fast. It might not be fast based on the amount of data you have, but it's faster than the others, and it's really easy to implement. So this is the basic or the key thing. You don't need to do any anything else. You just need to count the word, and the most frequent one is going to be the keyword directly. But of course, it has a lot of limitations. It may include irrelevant words. It might not be contextually understanding the data, and so on and so on. And of course, some of the applications are basic topic summarization and initial data exploration. But it's not really used in the keyword extraction for professional use cases. So TF-IDF is just weighting, it weights the words importance based on their frequency in the document and versus the corpus of the document. So this is, we will see how to do this, but the key features are it considers the corpus texts and highlights significant terms. The limitation, of course, are statistically its statistical approach may miss some semantic meaning of the word, which is also a drawback. But applications include document summarization, SEO, and topic analysis. Of course, we do have the topic modeling, which is LDA. It groups the words into topic based on the co-occurrence pattern. So if some words are occurring with each other, if they are co-occurrence, it would just group those words into topic. So some key features are it uncovers hidden themes. Sorry, it's useful for large collections, but it requires setting topic numbers. Interpretation can be challenging because you have already removed the top words and so on. So applications, of course, includes theme discovery and content categorization. Sorry. So the last one is part of speech tagging or nouns. So it extracts nouns as potential keywords and represents them as key concepts. So this, like, what makes this different from the others are it focuses on meaningful words, easy to implement with SPA CY, which is just a library that you can use. So it may include less relevant nouns and requires domain knowledge for interpretation as well. So some examples could be identifying key features or issues with app reviews. So let's see some like pros and cons. Just this is just a summarization of what we have talked earlier. So the frequency based is very simple, very easy, and fast to use, but it could give us irrelevant words, and it's not aware of the context at all. The TF-IDF is it considers corpus context, but it's statistically then, and it may miss semantics. For the topic modeling, it uncovers themes because it groups them into group, and topic numbering setting could be hard, and it may be hard to interpret the results, and you may need some knowledge about the industry and so on. And the nouns are focused on meaningful words, extracting meaningful words, but it may be less relevant terms and needs interpretation as well. Yeah. So examples of this could be, for example, the frequency you want just identifying the most common words in the reviews. The TF-IDF could be highlighting words that are significant across the data. And the topic modeling, which is LDA, could be grouping words into topics for deeper insights. So applications could be pinpointing user pain point, if it is cache, if it is slow. So if the keyword slow happens to appear a lot in the review, the company may need to find a way to make it faster and so on. It highlights the praised features, which the people love, which is intuitive, fast, and so on. And it also, this is very, very, I would say, key thing. It guides the app updates and the marketing strategies. So it's a really good thing to know. I think I took a lot of time. So yeah, so that's it for the introduction. So is it clear, guys? Do you have any questions? I think there's some questions here. Do you have any questions? Is it clear? I think we have seen it earlier, so it might not be a lot new concept. Which model do you recommend? So based on your data, your available data, based on your computational power and so on, it depends. So I cannot say this one is better and this one is not good, but yeah. Okay, Frau said, but when we remove stop words, the message of the reviewer wouldn't be clear. So that's the whole point. So there are like these models are trained to know or to analyze sentiment based on phrases. But like for the topic modeling, especially for the keyword extraction, if you don't remove these stop words, you're going to be seeing a lot of stop words on the top keywords. So we will see them. So don't worry about it. But when we remove, okay, I think if we select keyword, how can we train the model? So do you have enough data to train or to work with deep learning? I don't think so. I'm doing it for this project, at least it's not. But for the futures, we will see how we can do it. So text blob. So let's not decide right now before we try it. I would say like don't have a favorite model or don't have a favorite method. Just have a clear understanding of when to use what and what's the drawback and what's the positive side of everything. Okay, Proud? Yes, Nabil.
I'm just gonna say a lot of times I find it useful not to pick one, but just use different things for different purposes. So maybe for a high level overview, you can use a very rough frequency analysis of the keywords. And then later from that, as a next level of analysis, you can dig deeper, obviously based on the size of your data. And you might be able to do frequency analysis for the whole data, even if it is 100,000 rows, but you might do sampling. So you might only take 10% of that to do deeper analysis because you don't have a lot of computational power. So it's not like you don't have to pick one or the other. you can really, depending on your needs, you can kind of pick and choose, and you can even sample within your data to do some kind of analysis.
Yeah, that's what I was just saying. So don't have a favorite model or method to do analysis. Just have an understanding of when to use what's the drawback of each method, and what's the pros and cons. That's why I tried to just highlight them in order so that you will know which model to use when. And it's also good to experiment with all before deciding with one. So yeah, thanks for the explanation as well, Nabil. So if there is no question, I think we can move to the examples. Can we move, guys? Is everything clear so far, at least? Okay, good. So let's see. So it's kind of connected. So I have zoomed in. I hope you guys can see it. Frau, yes? Yes, Frau. Uh, Mute? Who, me? Or um, can you guys hear me? I'm confused. I muted. So I didn't mute you, if that's your question. I cannot. If you can't speak, that would be good. So I think you raised your hand. Yes. Okay. Maybe it was a mistake. Yes, Paul, is that a question? If not, you can mute. Okay. So can you guys see it? I have zoomed in. Is it enough? Okay, good. So the first one is just importing dependencies. For the sentiment analysis, we have text blob and we have the Vader one. And for the machine learning, we have sklearns. And of course, for cleaning it, we have NLTK, which is just the toolkits for natural language. And for the data set, I have used Kaggle Have for this example only. Sorry. And for the keyword extraction, of course, I have used, again, the sklearn. And for visualization, I used word cloud and matplotlib. Okay, so the first thing that I did was just download the NLTK resources. So let's run these things together. Sorry, I have to change places. Just 1 minute, okay? Okay, so so I just downloaded the stop word, the wordnet, and so on, the Punkt tab and the Punkt resources. So after that, I just downloaded the app previews dataset. I think I have it somewhere. Let me just check. Here, I think I have it here. Yeah. Let me just show you what it is. The dataset that I'm going to use. So this is the dataset that I'm going to use for the calling app, which includes like WhatsApp. I think there is some else as well. Sorry. It includes some apps such as the Telegram, the WhatsApp, Imo, Skype, and WeChat. So it has sorry, reviews, 10,000 row reviews for each one. So you can see it here, the values, where it came from, and the review itself, of course. So WhatsApp started being a problem, so I switched to this, and this has been superior for quite some time, and so on and so on. And of course, we have the score and the thumbs up score count for that specific review. We also have that one, and when it's created at, or we like a review created at, and the content, of course, this is a reply from the company. So this is pretty much it for the Telegram one. We have for the WhatsApp one. We also have it here. For the WeChat, we have it here as well, and so on. But for this one, I am planning to just work with the Telegram one. So I went ahead and downloaded it by using the Kaggle Hub, and it's going to print the path where it's going to download it. So it downloaded in like, let me do it again. It's going to change paths. Yeah, so it has downloaded it on the Kaggle folder. So here, under here, we have inputs, and then we have the coding app preview dataset. So in here, we have the email, the Skype, the Telegram, and of course, the WhatsApp and WeChat. So for this session, I'm planning to use the Telegram one. So let me close this one. So here you can see the row, the reviewer ID, the username, the user image if it has one, the content, what they said about the app, the score, the thumbs up count, and the review created version, and where it's created at, and of course, if it has any reply, plus when it is replied, if there is a reply, and the name of the app. So this is for Telegram. So the first thing that I did was pre-process or clean the data. By cleaning, I removed some punctuations, special characters, convert everything to lowercase, so that it will, like when, especially for the keyword extraction, we know it will not have any problem with like matching the words. Plus, I tokenized it, split it into words. Plus, I removed the stop words, which is eliminating common words such as the, and, a, is, are, and so on. And I reduced the word to its base form. So instead of running, run, rain, sorry, and instead of run, running, and so on, it's all converted into run. So that's what I did. So here you can see that for the tokenization, I used the word tokenizer method. I converted it into lowercase, and of course tokenize it, and then I reduced the word into its base form, and then I removed the stop words. I used the English dictionary in order to do that. So it has a lot of different dictionaries that you can choose from, and of course, and then just did everything together. And let me just show you, and put everything into the processed review column. Okay. So it just took 9 seconds. So let me just run this, and here you can see the pre-processed reviews. So here, WhatsApp started being a problematic. So being a is not something that we are interested in. So that has been removed. Problem. So I is not also improved, like in middle here. So switched. So here you can see the pre-processed text. WhatsApp started being problem, switched superior, quite, and so on and so on. Okay. Yeah. So I did that for the whole content. Yes. Yes, Abdul Mikhail. Abdul Mikhail, if you are speaking, you are on mute. Or is there
Can you hear me?
Yes.
Can you hear me now?
Yes, I think there's a lag.
Okay.
I think from your side. Yeah, okay.
On the third line, on the pre-processed text, on
Okay.
lemmatization.
Reducing to its base form.
Yeah. The method does not have any parameter. We didn't pass anything.
Yes. It's just word limitizer. It doesn't read any parameter. You just pass the word and it will limitize it. Limitize it.
Okay, just I was confused. That's why.
Okay. Okay. Yeah. It's just that's that. Okay. Is there any question, Fraul? I think you said you have a question, but you didn't speak when you were given the chance. So can you speak now, Fraul? Raul. Okay, if you cannot speak, just write it here, okay? Okay. So it's cleaned. So the word or the content is cleaned. So let's go ahead and yes. We need to include all the data pre-processed. Okay. Okay. So I think it's better to answer questions later. So so we have cleaned the data, and then now we're gonna work with sentiment analysis first. So we're going to take a look at the text blob method and the Vader method in order to do this. Plus, we will have advanced sentiment analysis where we gauge or where we compare the sentiment with the score or the rate. Okay. So let's take a look at text blob, which provides a straightforward way to classify sentiments based on the predefined dictionaries and extent. And so here I have what I have done is so the first thing that I will do is calculate the polarity of the sentiment, which is what you have seen earlier, which is like having a score, right? So from 0 to 1, it's positive. From 0 to -1 is negative, and if it is 0, it will be neutral. So I just assigned words to it. Okay, so if it is positive, it will say positive. If it is negative, it will just say negative, and if it is neutral, it will say neutral. Okay, so the number is good, but for this one, for this example, I just used the numbering. I mean the polarity score is also works. It does also works, but I want to see how many of them are positive, how many of them are negative and neutral. So that's what I did. So I will work on the pre-process review column and apply this sentiment and write the result on the sentiment column. So when I run this, you will see that I have out of the 10,000, I have 5,703 positive reviews, 2,212 negative reviews, and 2,085 of them are neutral. So that's my result by using the text blob. So the second one is Vader, which is more tailored to short text like reviews, accounting for sentiment, intensity, and informal language, which is just you can, like I've said earlier, you can think of it as rule-based. So I just used from the natural language toolkit. I just downloaded the Lexicon, the Vader Lexicon method, or I just downloaded it. So we have talked about what it is earlier, and then initialize it, which is a sentiment intensity analyzer, and then use it to just calculate the polarity, and it will just create the compound. And if the compound is in between 0, just like the earlier one, I just calculated it and assigned it value positive, negative, and neutral, and counted the values. So here, if we, I think it has been run, but so if you can see here, we have 5,000 400 for positive. So the value is different, right? For both are based on the lexicon dictionary, but the values are different. Of course, it's not a lot, but it's different. So this is the effect of the rule. Okay. So we have these values. So I think we can see how different they are from here. So here, for the first one, the sentiment or the text block sentiment analyzer has classified it as positive, but the Vader has classified it as negative. But if you take a look at the review, if you really take a look at the review, it's a negative review because the person was saying that they were using WhatsApp first and they switched to the Telegram app, but there is still inconvenience with the Telegram app. So they were happy with their choice of converting to Telegram, but the Telegram app still has some negative, some figures that they are not happy with. So that's when you take a look at the wider context. It's yes. Is that a question? Yes, Gabriel.
Thank you. When I see the VADAR and the text block, the result of the positive, negative, and neutral, they are a little bit different, yeah?
Yes, I'm explaining that one.
Uh-huh.
I was explaining it.
Yeah, but I see also the range of the polarity is also different. You put for the text block 0,
Yeah.
but for the VADAR 0.5. I think that makes also some change, yeah?
It's not for, so it's compound. So let's just take this. Let's say, okay, let's use content, but instead of content, why don't we use the preprocessed review? And then dot. So I think your question is, what if we apply this with a different polarity, right?
Yeah, yeah.
Okay. Then let's see. If it's different, it shouldn't be. Yeah, so it's still different. If you can see, 5,000, 192, 2,000, and so on and so on.
Okay.
Yeah. So Abdelmikael?
Yes, can you hear me?
Yes.
I have seen something around apply the analysis on both in text block and VADAR. If we see on text block, it took pre-processed review in order to do some content analysis, but on the VADAR, it took the original one. So maybe.
Yeah, you can see also it will still be different. So here, if on the pre-processed, you can see that it's different. But you are right. We should have used we shouldn't use a different one for all. So it doesn't change for this one, of course. For the for the second example, let me just remove this one. I think it's better to do so, but it doesn't really affect it that much. Of course, there is a difference. If you can see it here, it's 6,000. So that was a mistake. We should have used the same row in order to compare it. So that's a good thing to notice. But yeah, good. Thank you, Demkade and Gabriel. So yeah, so if you can see here, there will be some things that are considered positive by one method and considered negative by the other. But here, for most of them, it's the same for some reason. Yeah. But yeah, like for the total, you can see that it's different for the text blob and for the Vader. Yeah. Hey, for the advanced one, so what I did was I just used the rating as label for the reviews. So if you can see here, we have the row score. So I use the score. So if the user gives a higher score, it means that the review is positive, and if they give a lower score, it means that the review is lower or negative. So use the stars for as a label. So 4 and 5 is positive, and 1 and 2 is negative, and 3 is more of a neutral. Okay. So here it's just a label, and then we just vectorized. So I used the TFID vectorizer and vectorized the pre-processed reviews. And for the Y, I used the label and split it into text, test and train. I used 20% of the data, which is from the 10,000, 2,000 of the rows are going to be test, and the 8,000 is going to be used for training. So yeah, we just do that, and after training it, I used it to predict the test, and I just compared the result of result of Y, which is the prediction of the model, with the result, the original result that I had, and the accuracy is, let's see, around 0.75% or 75% accurate. So with this model, we can see if, like by seeing or by looking at the score, we can say it's a positive or a negative, and just rely on the, I think it's better to rely on the label. So on the label, you can see this is a neutral just because the score is 3, and here it's going to be a positive since the score is 5, and here it's 3, so it should be a neutral, and here it's a 1, so it should be a negative. So it's mostly the same for most, but for some, so it has identified it as neutral, but the 3 models has identified it to be a negative, and they have identified this to be a negative, but it has identified it to be a neutral, and so on. So it's basically depends on the score. That's why you see a difference. Okay. Okay. So is that clear for this part, guys? Okay. Okay. Good. So let's see keyword extractions. So for the keyword extractions, I used TF-IDF method, which we have discussed earlier. So it identifies words that are important. It gives them weight based on how their frequency and how many times they appear and so on. And how it will identify how important the words are in specific review relatively to the entire dataset. So it just used the the vectorizer that we used earlier, plus it vectorizes and fits the pre-processed review, which we did earlier for the machine learning method of the sentiment analysis, and then just get the keywords by vectorizer, get feature names out, and the keywords are here. You can see able, account, add, also, always, app, application, and so on and so on. So bad, connecting, and so on. So it might not be the best thing because we just ran the code. We didn't do any cleaning up. So great group in internet issue keep. So like depending on how often these things are appearing in the text, you can so able. So why do people are using the word able a lot? Account, what's the issue or the good thing related to account that we have with our feature? Adding also, like, also should have been removed when we remove the stop words. Always also could be removed. App and application should be the same thing. So this is why we need cleaning. Okay, so app, application, and apps should have been the same thing. When we reduce them to their base form, we should take a look at. We should be careful in order to just remove these things, because of course it's just a duplication, right? Bad, best, better, big. So if the word big appears a lot, so we should check on these reviews and check what the big is and prioritize it if it's happening to a lot of people. Channel, chatting, connecting, and so on and so on. Okay. Okay, so we have seen how we can do sentiment analysis. We have seen how we can extract positive things, negative things, we have seen how we can identify if a review is positive, negative, or neutral, and so on. And we have also seen how we can extract keywords. So how can we put these things together? Or how does these two things fit like into one thing? So one thing is we can filter out positive and negative reviews. So the first thing I did was here from the sentiment. So I used the text blob method result here. So for the sentiment, from the sentiment analysis, I extracted the sentiment where the sentiment is positive. I just extracted it into the positive reviews, and for the negative, I just extracted the negative one. And then we vectorize positive reviews and of course the negative reviews by using the TF-ID vectorizer, and just transform and feed them and extracted the top review keywords. Sorry, and here we can see the top keywords for positive reviews are up. Also, up is present in bad, in both. Best is more present in the positive reviews, and bad is present more in the negative reviews. File, so good, like, please, problem, telegram, update, and videos are words or top keywords that are found in the reviews, in the positive reviews. And the word bad, connecting, so there's some issue with the connection. Download, so there's some issue with the download. Maybe they cannot find it after downloading, or they are not able to download, and so on and so on. File, there could be something wrong with the way the files are saved, and so on. Telegram, please. So these two words are actually a repetition. Time, update also is a repetition, and video is also a repetition. So this might mean, so people are maybe actually, if what would happen, I'm curious, if I just change is to I think we have the reader sentiment, right? I think it's going to be a lot different. Yeah, let's use this one, or yeah, let's use this one actually. So what if we use the reader sentiment? Yeah, okay, let's just run this one. So it has some different words such as was problem problem previously was part of the positive reviews. If you can see here, which doesn't make sense because problem being a part of the positive, but here it's part of the negative reviews. Telegram time update and videos are pretty much the same thing. Fix, of course, is here, updated here. CA, I don't know what CA is, why is it happening here? So we need to do a further analysis on that one as well. But yeah, you can see that the message is part of the positive keywords, but for the rest, yeah, it's the same. So this was just out of curiosity. So we have seen how we can connect the two here. This is just one example, okay? Just one example. So let's see let's visualize some of these results. So we can use the bar chart to show the distribution of the sentiment, the positive, the negative, and the neutral sentiment. And so we can use the word cloud in order to visualize the frequent keywords in positive and negative reviews. So here, what I did was just for the bar chart, I just used green, red, and blue for the sentiments, which is the positive, the negative, and the neutral, and just counted their values. So here we can see that we have more positive than the negative, but we have more negative than the neutral, but it's very close and so on. And for the word cloud, it's just a collection of the words that are repeated. Yeah, this is just keywords. I would say it's just it's just the keywords. So here we have Telegram, message, update, app, video, features, download, good, thank. We have good again, chat, problem, please, and so on and so on. So I think it used positive reviews, yes. And for the negative reviews, we have used this. We have done the same thing, but just for the negative texts. So here we have the Telegram, still a bad, worst. They even use chat, message, account, and so on and so on. Phone issues, delete, updating. So you can annoying notification and so on. So you can tell that these things are negative reviews. So the word cloud just helps you visualize them. So yeah, so that's it from my side. Do you have any questions? Yes, Nabil.
I was going to say for the word cloud and for some of the data analysis, would it have been better to flag words like Telegram and maybe words that repeat a lot between positive and negative as stop words in a custom dictionary, so that your positive and your negative top words would be a lot more diagnostic? Would that be something that would be appropriate?
I think I have missed the question. So are you saying that?
So I'm saying that, so can you go back to the code?
Yeah.
So you know how you have in the positive words and the negative words, you have some common words, like you have Telegram, and then you might have, I don't know, say app would be another word. You know, and then please would be another word. So would it make sense to kind of take those words, add them into a custom dictionary to concatenate with your stop word dictionary, and then you take them out of your analysis so that you can have, I guess, better diagnostic precision for your positive and negative words. So then instead of Telegram being the big word in the word cloud, or instead of app being the big cloud, the big word in the word cloud, you start to see the real words that express user frustration or user happiness.
Of course, yeah. So that's part of cleaning, right? So when you clean that's it, you need to do those things prior, or when you see that the Telegram. Sorry, I think that there is some sound in it.
Sorry, say that last part again. You cut off a little bit.
You have a lot of noise from your side.
Oh, is it better now or no?
Yeah, it is. So I was saying that you need to do some cleaning after, like prior, like I was saying that the word please, some of the words, so application and so and these things should not be here because like the stop word missed to clean those. So when you see these things, you need to go back and do the cleaning again or remove this word. So Telegram should not be here because it doesn't make sense. Good should not be here, so since it doesn't make sense. So these things are just further cleaning that you need to do after. Yeah, so it's not a one-time thing. It's more of an iteration. So
I
you will,
understand.
yeah, you will need to clean it after in the process of iteration. Yeah,
One
but good.
other, sorry, go ahead. I didn't mean to interrupt you.
I was just saying it was a good point, but it's just part of the iteration.
Okay, and I have one other question. My other question is it possible to use those words not in isolation because they're not very useful like that? But could you be using it as part of, in combination with other words to look at actual problems? So, for example, maybe take Telegram and you can combine it with like maybe like connection or combine it with that. Is there techniques to combine that to do more
Yeah.
advanced analysis?
Yeah, so that's part of, so that's what we mean by when we talk about phrases. So now we have seen just words. So we have extract keywords, but when you extract key phrases and when you use the noun method, well, that we have seen earlier, you could extract these things. So it will just not remove the nouns around it, and it will give you uh, more meaningful results. So instead of Telegram, it might be like good something, maybe good Telegram has a good connection and so on. So phrases could solve this problem, but right now we just extracted the keywords.
Okay, thank you. Sorry, that's it for me. Appreciate it.
Question. Thank you for asking, Nabil. So do we have other questions? I think we have some questions. So do we need to include all the data pre-processing and sentiment analysis steps used present in the lecture of as part of task 2, such as mentioned in the presentation, included in the challenge document? So these are just stop removing stop words and so on and so on are just part of the cleaning. So don't expect everything to be like every single thing to be presented in the challenge document. So of course, if you think that you don't need to clean the data, if you like imagine or if you accept the data to be cleaned, you can just dump this this step. But what I would advise you to do is first do it with the whole data. Since you already will have the whole pipeline, you can just do the first part without cleaning it and see the result, and just remove the stop word, reduce it to its base form, and so on and so on, and do the whole pipeline again, and you will see the difference. So I will guarantee that there will be a big difference between the two results, but it's a good thing to see. And then mass, what does the block text? I don't understand this question. Maybe he's referring to the code. Not this one, but here. So it doesn't even have. So okay, are you thinking about this? So this is going to take in the text and process. So do the analysis by using text blob. So it takes the text and do the analysis, and from the analysis it will identify if it is positive, negative, or neutral. So it's just going to apply this function over the rows of the review. So if is that a question, if you can speak it, that will be better, because text blob text is just text the text and do the analysis, but I don't understand text data. When we record different language, how does this method apply? So we have a lot of different dictionaries that help us. Of course, we don't have, I don't believe, I cannot be 100% sure, but I don't believe we have the dictionary for Amharic and like our local language. You can do further research on this one, but for the other language, we already have dictionaries that help you with this. So you just need to load those dictionaries as we have done for the Vader. You can see here you can just download the resource and just perform the analysis. Would you share your slides? Yes, it will be shared as always. I'm Mikhail. We have 3 methods of sentiment, explore variation, and how do you compare this correctness and decide to use one of them. Okay, so that's an interesting question. So that's where judgment comes in my opinion. That's where you come in. So we have the 3 results. So you can do your own analysis on them where they differ. So here, especially for the machine learning for this specific example, I don't think it's good because it heavily depends on the score in order to say if it is good or bad and so on. But of course, it has a good, it's not a good actually. I would say in the top middle or top half. Sorry. Based off the accuracy, so that's a good thing, but I wouldn't use it for this example. So the rest are just like comparing between the weather and the text blob sentiment. So as I've tried to mention earlier, so the weather is more equipped to do analysis on reviews and so on. So this might be better. So do your own analysis where the results are different. Just take a look at where the results are different and do your own judgment for a few data points or for a few rows and decide on which one to use. If our review is in Amharic, how do we perform sentiment analysis? So this is where the machine learning and the deep learning comes in handy. So if you have a labeled data, you can just train your own model on those one and have a better result if you don't have the dictionary as a language does. But for now, yeah, maybe we can for the future we can work on it. So is that clear, guys? Maybe if I am going off topic. Okay, good. Yes, Gabriel, you can go. Gabriel, what you were about to speak? I think I stopped you. Is that a question?
No, that's a question.
Okay. Okay, good. I think we are actually over time. We have gone over time, so we can stop the session. So is everything clear? Do you have any questions? If not, I think we can end the session here. Okay, good. So as always, if you have any questions, please do ask on Slack. Just reach out to me and we can have a discussion on this one. Where you post the slide. So I will post it on Slack on the resource, and of course it will also be posted on the drive for week 2, the technical content folder. So just take a look at both places and you will find it. Okay, thank you guys and have a great day. Bye.